Ladies and gentlemen, it is 4 p.m. on Tuesday, 8th of December 2020. That means it is time for December's epic product launch. Live from Mission Control in Northbike by the Sea, we have selected 6 epic members who each have an important development to announce to the rest of the world. Today, those companies are Focuslight, TOPTICA, QuiX, Aixemtec, VPIphotonics and Holo. And with the help of our media partner AZOnetwork, let's open up the Zoom room and get started. Thank you very much everyone for joining the epic meeting for new product releases. This is the news show of Epic, the event in which we highlight new things that happened over the last month. It's a monthly event available for all the epic participants, all the epic members that they want to participate. We have now 651 members as of this morning. Thank you very much for the great support that the industry keeps giving to the European Photonic Industry Consortium, the biggest association in photonics in the world. And today we have fantastic 6 companies presenting: Focuslight, TOPTICA, QuiX, Aixemtec, VPI and Holo. And we kick off the show with Holo, with Focuslight. Thank you very much, Choho, for being with us this afternoon and for telling us about the 905 nanometer laser transmitter for beam steering LiDAR system. Focuslight is the company that, after the acquisition of Limo, brings together semiconductor lasers and micro-optics for the best beam shaping and accuracy that semiconductor lasers have ever seen. Thank you very much, Choho, for this presentation you're about to give. The floor and the attention of everyone goes to Focuslight, goes to Choho. The floor is yours. We have you still muted, so if you unmute yourself, we can start hearing you. Yes.
Yes, fine. Okay, thanks for the invitation from EPIC, and also thanks for the introduction from Dr. Jose. And it's my honor to present Focuslight to share with you the latest updates on short post. Excuse me, just one moment. Okay, just the latest process on short post high peak power 905 nanometer laser transmitters for beam steering LiDAR system. So my name is Holo. I'm the project manager and Focuslight. And okay, in the mainstream market, the mechanical rotating LiDAR is the main technical solution. And to increase the accuracy of the rotating LiDAR, multiple channels of laser chips are being utilized. However, the more channels we use, the high complexity of the system as well as the high cost we would have. So to solve this pain point, Focuslight came up with a solution of using a single laser bar combined with a small high-quality laser optics to build a pure and clear line for beam steering LiDAR. This would significantly reduce the complexity of the system as well as the size. And in Q3 this year, Focuslight has launched a 905 laser module for LiDAR application named LE01 with peak power up to 300 watts and post width around 4 nanoseconds. And what's more important, the updated version LE02 with peak power up to 800 watts and much smaller size. And it would be released in Q1 2021. And this one is the LIV test result of the LE01. You can see that the peak power is around 300 watts and the short pulse is around 4 nanoseconds. So in order to sustain upgrade application, so we have tested the power of LE01 and the high and low temperature. And we can see that output power goes down by half as ambient temperature rising from 25 degrees to 130 degrees. And operating temperature is from minus 40 degrees to 130 degrees. So this is very good and very suitable for upgrade application. And to increase the accuracy of LiDAR application, so Focuslight highly recommends the fast axis collimation lenses for laser transmitters. After collimation, the divergence in the fast axis could be squeezed or minimized from 30 degree to smaller than 0.4 degree, or even lower than 0.1 degree, according to customers' specific requirements. And as on the aspect of slow access, Focuslight can also provide unique optical solutions to fulfill customers' specific demands. For example, the homogenizer, as shown in this slide, can provide uniform and flat top distribution in the slow axis. And this can realize a large FOV design and very suitable for outgrade application. And now, so this is Focuslight. Focuslight is founded in 2007, and it's a fast-growing company that develops and manufactures high-power diode lasers and micro-optics. And now Focuslight has 4 business units. They are diode laser, laser optics, automotive, and optic systems, and operates from 4 facilities globally in Xi'an, Dongguan, Haining, and Dortmund with over 600 employees. And Focuslight has made a great process since entering automotive LiDAR system at LiDAR market in 2018. And in 2020, this year, Focuslight has launched its first full solid-state laser module, AL01, for flash LiDAR in mass production for a global tier 1. And furthermore, Focuslight has obtained the official certificate of IATF 16949, which is very important for automotive manufacturing. And this is my ending of my short presentation. And also thanks for attending. So it's my honor. And if you have any questions or any suggestions, please contact us.
Thank you very much, Holo. I like that this is your WeChat QR. So please everyone scan him for having in WeChat. I will do it myself as well. And it is great to have Focuslight at the event today addressing the LiDAR market. Of course, if there are any questions in the room, please feel free to ask them just by saying so in the chat. I really love that you show us this slide and you talk to us about the operating temperature that enables the automotive market, the auto grade operating temperature. But being in the automotive industry is beyond the temperature degree. How has been the process for offering this technology to tier 1 suppliers? Is there any automotive qualification beyond that?
Okay, thanks for the question. And I think that as for the when you're talking about the upgrade verification, this means that this component should be tested under specific standards. And I think, and because this material for the optic components is glass, so it's very suitable for upgrade application. But if you, but we will just get more data for the verification. But right now we don't have much data, and we should accumulate more. That's right.
When we talk about the output power that you have, and it's extremely high. So first of all, congratulations on that kind of output power. This is very high peak power, and you are addressing the LiDAR market. 905 nanometer is quite a nice wavelength. But when it comes to eye safety, are there anything to think about, any considerations?
Yes, that's a really good question. So when we're talking about eye safety, so we should take about the energy purpose. Yes, so it should be so the energy should be controlled within safety zone to protect the eyes. But I think that for now we wanted to show that Focuslight can provide a very good optical solutions for the LiDAR company. So LiDAR company can cooperate with Focuslight to build a very good LiDAR production to fulfill the function and also to protect the eye safety of the passengers. Yes.
The presentation is there, and now all the companies that are looking for scanning LiDAR solutions will be contacting you, Holo. Yes. But I also would like to do more business than that, because earlier today, Kenneth Ferry from Focuslight contacted me and showed me a video of the facilities, and I was quite amazed on the burning test, on the real-time test. I want you to meet a couple of my friends today here. I have Jan from Aixemtec. Jan, good afternoon. How are you doing? All the way in Aachen, next to Bremen in Germany.
Thanks, I'm good.
You know what the Focuslight do? They acquire Limo, and they have micro optics, and they have the semiconductor lasers, and they have a process to aligning the micro optics on the semiconductor laser for fantastic beam steering and fantastic beam shaping. How could Photonics help a company like Focuslight?
So Photonics is a specialist in microassembly of micro lenses, and we have special routines for aligning beams, making beam profiles on the machines, and have huge hardware for all the feedback you need on the systems.
The Photonics is specialized in the active alignment. Later on today, you're gonna hear from Aixemtec also in the active alignment. For some of the volume production, passive alignment is also interesting. I have Herman Moss from Fintech all the way in Berlin. Herman is a good friend. Herman, how are you doing today?
I'm doing great. What about you?
I'm doing fantastic. When I see you, I get happier. How do you think Fintech could help a company like Focuslight?
Well, we can, just as you actually mentioned, if they're looking for something like passive alignment, we can basically pick and place their dies and align lenses with snap curing using UV epoxy and so on, which we also did already for some other companies. So I think we know what it takes actually. So feel free to contact us, send us some samples, discuss your specification with us. We have, as you know, we have an office in Shanghai, so it should be not too far away actually from your factory.
Thank you very much, Herman. Joho, really nice to have you with us. Stay tuned because the next presentation is about DOEs, and you're going to find it extremely interesting. We go now all the way to beautiful, beautiful Israel. We go to Natan Kaplan, who's going to talk to us about the DOEs that they use for beam shaping for welding applications. And when it comes to DOEs, Holo has made a referential point for the photonic industry, especially with EPIC members. Many EPIC members are working with Holo, getting the right diffractive optical elements that they need for these systems. Natan, thank you very much for being with us on this afternoon, and tell us the unique adjustable beam shaper for welding applications. The floor and the attention of everyone in YouTube and here is yours.
Thank you very much, Jose, for this very kind introduction. It is overwhelming as always. So, and thank you everyone for being here with us. So my name is Natan Kaplan. I'm the CTO of Holo. For those of us that do not know us, we're a component manufacturer and designer for high power lasers, specifically micro optics and diffractive optics for beam shaping. I'm sorry, but it seems that my presentation is not at the start, so let me move it a bit here. So Holo was founded more than 30 years ago, and for all that time, we've specialized in working with the integrators in the field of material processing, aesthetics, and other high-power laser application technologies. We use our own design and in-house production to produce diffractive optics to give a wide variety of application results. Basically, for those of you that are less familiar with them, diffractive optics are thin, window-like optics that have etched phase gratings on their surfaces. These phase gratings allow one to manipulate the phase and achieve various effects, including beam splitting, beam shaping, and any other effect that's interesting to achieve in such applications. DOEs have a lot of advantages compared to traditional refractive optics, including absolute angular accuracy. They have no tolerance because we produce them in semiconductor methods. They have high LDTs, being flat and with low NA, and also thin, compact, and easy to integrate into existing systems. So it's all fine about DOEs and what we can do with them, but today I want to talk about a very specific application that we're launching now, the application Delight family of diffractive beam texturing, which is Delight stands for diffractive laser induced texturing, Delight. And what is Delight? So on June this year, we've published a scholarly article on the Journal of Laser Engineering. You have the DOE here. About a method to do laser texturing. Now, laser texturing, as some of you may know, is a highly growing field, a lot of interest in texturing surfaces to achieve various functionalities, tribological functionalities, increase of friction, reduction of friction, antibacterial, anti-icing, hydrophobic. We all know these beautiful videos where you have drops rolling off the surface. It's all done with various methods of texturing, and laser texturing is especially attractive because it has no residue, you need no materials. And as part of the Prometheus project, Horizon 2020 Prometheus project, we were very exposed and still are to the considerations behind this sort of texturing systems, and we came out with a new approach of how to do texturing much simpler, we think, and more robustly compared to other methods. So this was introduced in this article, and basically the concept is very simple. As you see in this image here, the optical system is very common to normal industrial systems. You just use one diffractive optic, the light splitter, and then you can use any focus optics you wish, for example, an f-theta and scanner or some focusing objective with a large field, and can achieve a very large number of spots, more than 2,500 spots over fields of 1/1 millimeter or a narrow pixel that is more line-like. And these fields can be stitched to cover large areas. Now, by itself, this concept is not so groundbreaking, but usually when people work with beam splitters, these spots are few and far between. In this case, this is more like a beam shaper. The spots are very close. They cover 50% approximately, or any other fraction that's desired of the surface, and can pattern with a single pulse a large area. This is a very simple and robust solution with good uniformity and inbuilt flat top distribution. You don't have this sort of Gaussian distributions other methods for this sort of texturing give you. So it's all fine and well in theory, but we, of course, had to show that it works. So thanks to a collaboration with our partners at HiLase Czech Academy Laser Center, we have now established this as a working and valid solution. I will now show you a video of a demonstration done last week, an experiment with one of our elements, a D-Light 805 element, which was used to create a pattern of 1/1 millimeters on stainless steel. This pattern was then scanned with an f-theta, and you'll see the results here. If the video would then work. 1 second. Okay. So as you see in this video, we have approximately 16 square millimeters being patterned in 1.2 seconds, which is theoretically impressive. And you can see the patterning results here in the close loop. These are really initial results. It was not optimized, and it's not the highest rate it can reach. But you see relatively good uniformity of these spots with a pitch of 20 microns. And basically the processing speed achieved here with a simple off-the-shelf setup was something like 0.06 millimeters square a minute. Of course, industrial rates is for low-end applications such as dishwashers or white bodies is something like 1 meter a minute, but it is definitely relevant and can be easily increased by parallelization or other methods. It's more than 2,500 holes per pulse, and this was only achieved with the HiLase parallel laser, which was a very impressive laser per pulse energy. So I would like to thank our partners at HiLase for using this laser. It's a thin disc laser that can give you high energies per pulse and has good beam stability and very low m². And with that, we could achieve these results. Basically, we could achieve much closer and denser pitches than these 20 microns you see here by using stronger focusing optics. We have designed in Holo and focusing objective that can reach a pitch of 3.5 microns for the IR. And if you go to the UV, you can go below 1 micron pitch with this sort of patterning. And of course, the advantage of the D-Light method is that you can not only just pattern with Gaussian spots, you can also pattern with edge structures or create a sort of grid line structure using interference effects between the various spots. And thus you can achieve results that are not possible in traditional methods for laser interference texturing. Thank you very much for your attention, and I'm open to questions.
Thank you very much, Natan. You didn't put the QR code for WeChat, but you had the email address, so feel free to contact him, to contact Natan for anything regarding the DOEs. These guys know what they are talking about. But today he talked about surface functionalization. And of course, this is super interesting because we know we can make easy to clean surfaces, we can make antibacterial surfaces. It's really great. But we have a problem, which is the speed. Is there a way that you can aim for a multi-beam solutions? Can DOE play a role on that?
So basically, this is a multi-beam solution. Our DOE creates a pixel that is already containing 2,500 beams. So the only limit is the laser power. If you have more laser power, we can open the pixel larger and you can increase the throughput. Sometimes it makes more sense to use several low power lasers, of course, like in this case with the parallel, of course, if you would like to scale it up. But basically, this is already a multi-beam solution. It comes packed in one. The pixel that they were scanning was a square with 2,500 spots.
Indeed, normally for the surface structuring, we are looking at peak powers of hundreds of watts to kilowatts. So having a multi-beam only with the DOEs could be a limiting factor, but you can enable it. So you just need the right power from the right laser sources. So I'm here calling for companies like Coherent, like Fluence, like Trumpf. These guys can split your beams at high power, at very high power. So you can actually do this for the multi-beam solution, very low cost. You know, today, Natan, we had the press with us. Oliver is here with us from Photonics Views. Oliver, good afternoon. Thank you very much for joining. You saw the presentation from Natan from Holo. They can do beam splitting for very high powers. Is there anything resonating with you on this in the surface structuring?
Yeah, hi. I was a bit late. Sorry about that. But I do actually have a question. We had articles recently that were dealing about surface structuring with multiple laser beams. So what's the advantage of having one particularly strong source and splitting it up with a DOE in comparison to having multiple sources?
Thank you very much, Oliver, for this question. It addresses a point that I failed to make in the presentation, but is very important. Basically, the idea in such setups such as, for example, DLIP, direct laser interference patterning, where you write with multiple beams, is that you need a system that is usually not optically simple. You need multiple prisms or a setup that is relatively complicated and usually needs alignment in terms of tilt. In our setup, you use one large beam, so energy density is not a problem for the components, and one component is completely unsensitive to centration. And you get the same sort of result with a much simpler optical system, much more familiar to, let's say, industrial optics, f-theta, scanner. It integrates and meshes well with what current integrators know how to work with. It does not need a sort of a different animal, yes, like in the direct laser beam interference, where you need to use special prisms and a sort of beam splitter in diffractives. Also, it's more efficient because you're wasting less energy on components in the middle of the way. And you're more flexible because there you have the Gaussian envelope. So you need to make a flat top beam from the input if you want a flat top envelope. Here you have it built in and you can play with things. The spots don't need to be Gaussian. They can be, for example, edge structures to create something like riblets, which is very interesting for many people.
Thank you very much, Natan. We have a company in the room, Opto Sigma. Axel Haunhofter is here to, and he told me that they are doing quite a lot of work on LiDAR scanners, and I think there could be some room for cooperation here. Axel, what work are you doing on LiDAR scanners?
Yeah, thanks, Horst, for the introduction. So we see also that the demand on the faster scanner options are more and more driven. And for this, some people changed from, I mean, it's not the hologram, but from glass material to silicon carbonate optics. So because of the higher E module, you can you have better resonance effects in scanners, and also you have a better E module. That means you have less tolerance effects on the laser processing. That means like normal LiDAR scanners, the rotation ones, but also the turning mirrors for X and Y. And you see there, an improvement because time is money every time.
If you want to get in touch with any of the participants today, this is for the people in the Zoom room and the people in YouTube, all you have to do is send me an email, jose.pozo@epic-azog.com, and allow me to shift gears. We go now to Enschede in the Netherlands. We're going to meet the CTO, Jelmer Renema, who is going to talk to us about a 12-mode quantum photonic processors using photonic integrated circuits. This is magic. Thank you very much, Jelmer, for being with us this afternoon. We all want to hear what you're doing, and we all want to help you doing it even better. The floor and the attention of everyone goes to QuiX, goes to Jelmer.
Hi, thank you for that very kind introduction. My name is Jelmer Renema. I'm the CTO of QuiX, and I'm going to tell you something about the 12-mode universal quantum photonic processor that we are putting on the market. So what is a quantum photonic processor? It's the processing unit of a photonic quantum computing device. So what it does is it takes input quantum light and transforms it into an output quantum state in such a way that the answer encodes some computation that you want to do. So what this looks like in practice is you have a bunch of single photon sources that generate your quantum light. You have a large scale interferometer, and then you have a bank of detectors that read the output of this computation. And what is very important is that this interferometer needs to be programmable, because the problem that you encode via setting the optical transformation that this interferometer makes. And so what happens is that photons that have disappeared off my slide make their way through this interferometer, and when they encounter each other in the processor, they undergo quantum interference, they generate entanglement and superposition, and eventually arrive at the detectors where the pattern of output clicks encodes the answer to some computation that you might be interested in. There we go. And so what is very important is that these photon sources and detectors, they have been commercially available for a while now, but these processors are not. And this is what we are now changing. So what we are putting on the market is a large-scale, phase-stable, fully reconfigurable quantum photonic processor. And this is a picture of it. This is standing in our lab at the moment. This is what it looks like. And this is what is inside this box. So you see here the photonic chip. We realized this, as Jose said, in integrated photonics. And this 12-mode universal quantum photonic processor is the world's largest universal quantum photonic processor. And it is commercially available. So we have, just to show what you can do with this thing, just for fun, we have implemented many optical transformations, including the Q and the X of our logo. So you see here the Q slowly morphing into the X and back. We implement all kinds of optical transformations, and we show that this processor is universal. So what it can do is it can take any input light field over these channels and turn it into any arbitrary output light field. We've also demonstrated that this processor is suitable for quantum information processing applications by demonstrating high visibility quantum interference. And so, as I said, we have built and benchmarked the largest quantum photonic processor in the world. We're going to hold a full product presentation this Friday at 1500 CET. So if you're interested, go to our website, www.quix.nl, and sign up, or scan this QR code, which takes you directly to the sign-up page.
I'm going to leave it there. Please scan the QR code. What QuiX is doing is truly, truly fascinating. They are 2-3 years ahead of other companies who are trying. I am very impressed that you managed to put already the quantum processor in the market. But the question, of course, is very clear. So quantum processors process qubits, not modes. What is the relation between qubits and modes?
So there are different ways of encoding quantum information. So in a regular qubit system, the information lives in a series of two-dimensional systems which you concatenate together. And in this case, the information lives in the position degree of freedom of the photons. And we actually have a Medium blog these days, so a blog on Medium, where I have begun answering these kinds of questions. So I guess I can post this in the chat somewhere. There we go, where you can read a full technical answer.
It is, for me, quite impressive also as a proof of the maturity of the technology. Whenever you are aiming for a design that scales up in a way of integrating more and more interferometers, you need this to have a very high yield of the technology. But for your particular application, do you need all the interferometers to work, or can you work with, let's say, 95%?
So the whole interferometer needs to work. But this is not a process that let's say in the fabrication requires perfect yield, because you fabricate these things and more than one of them fits on chip. So what we actually do is we just test a bunch of them and we find the one that works the best, right? So it's in some sense tolerant to some fabrication imperfections.
One thing that is, of course, always relevant to you is that you are ahead of the technology. You are solving a problem that is not yet fully addressed by the companies. Which are the profile of companies who, in your opinion, should be talking to you to address some challenges of today or challenges for the day of tomorrow?
Well, I mean, first of all, we're of course very interested to talk to integrated photonics foundries. Then we're interested to talk to companies that make single photon sources. So there's a bunch of those, like Candela in Paris, for example. And then we're interested to talk to companies that make the single photon detectors. And there's a bunch of those. There's one in Delft, and there's one that recently started in Münster, Pixel Photonics. So these are the kind of companies that we are interested in talking to.
So he's calling for single quantum, calling for Quandela, calling for other companies that can make single photon sources and detectors to look for cooperation.
Absolutely.
And also open to work with any foundry that could manufacture this in the high yield and in the volume production, because we are talking about a quantum processor solving quantum computing issues. So the volume could be huge in the coming years. Jelmer, thank you very much for a great presentation, and stay tuned because the next one is very, very interesting for you. We're going to go now to Chris Maloney, because he's going to talk to us about the new software solution that they offer from VPI. And for those of you who don't know VPI, these guys made a revolution. They designed photonic circuits in the same way that anybody would design an optical network, making this transition in an automated design manner. Thank you very much, Chris, for being with us today. I want everyone to understand what you do because there's so much room for cooperation in this room. The attention of everyone goes to you, goes to VPIphotonics.
Yes, thank you, Jose, for that great introduction. And yeah, I'm excited to present today about our new software version for photonics and optoelectronics design. So namely our VPIphotonics design suite. We just released version 11.1. So at VPIphotonics, we believe in empowering you to define the cutting edge. And we do that through our photonics design automation software that's integrated, it's interoperable, and it's industry leading. So our VPIphotonics design suite is integrated in the sense that in the same user interface and design environment, we have component design for fiber optics and photonic integrated circuits, as well as optical transmission system design, all in one user interface. It's also interoperable with many of our partners' third-party softwares, as well as for co-simulation with Python and MATLAB. And today what I'm going to talk about is how we are leading the industry in terms of our capabilities and feature enhancements. So today, here's the list of what I'll quickly discuss today: probabilistically shaped QAM, digital signal processing, PAM4 signal analysis, and many more. So let's jump right into it with probabilistic constellation shaping, which has been a hot topic for long-haul systems. So by sending certain symbols more or less frequently, the signal-to-noise ratio can be improved and increase the capacity of a channel. So our software already supported PSQAM, but now we have a dedicated module that generates a polarization multiplexed optical signal with PSQAM. And you can see the new module here. And if you take a look inside, you can see the hierarchical nature of our software, and you can see both the electrical and optical building blocks needed to create this transmitter. Next, we have a few advancements in DSP. Two in particular are our new carrier phase recovery algorithm for PSQAM and an updated TDE MIMO algorithm to work with binary phase shift keying. So for the CPR algorithm, we implemented a two-stage approach shown in the block diagram that uses a modified Viterbi search that's PS aware, followed by a maximum likelihood phase estimation. So in addition, the new software version contains a number of application demonstrations utilizing these new blocks. Now for short reach interconnects, the pulsed amplitude modulation is widely used, especially to enable faster speeds. So for this purpose, we implemented a new analyzer for PAM signals, which can calculate a number of metrics. If you look at the plots on the right, You can see the eye diagrams for PAM4 system. And with our analyzer, we can calculate and quantify these metrics and therefore optimize parameters around such metrics. So in this case, we've actually optimized, going from the left to the right plot, the bias current of the driving signal based on the eye skew and symbol error rate. But it also supports calculating a number of other metrics like eye height and width, linearity, outer OMA, and many others. We now also support the capability of SPICE co-simulations for detailed modeling of electrical circuits. And this allows us to model the individual electronic devices, specifically laser drivers and TIAs, but also equivalent circuits for optoelectronics. So you can see in this example on the right, we have our VCSEL model here, which takes an electrical input and outputs an optical signal. So with SPICE co-simulation, we can model how the VCSEL is seen from the electrical driver and how it affects the behavior of those driving electronics. Earlier this year, we announced a detailed circuit level model for a silicon microring modulator. And after taking those initial steps, we've now developed a system level model. And that's composed of a linearized equivalent circuit and also a dynamic ring resonator model that simulates the optical behavior based on the electro-optical modulation of the MRM waveguide. And the functionality of the module is illustrated with several new application examples. The small block here is the MRM. And the plot on the bottom demonstrates the nonlinearity of an optical PAM4 signal generated using the MRM model. Lastly, we've introduced new features for the simulation of short reach multi-mode links and space division multiplexing systems. Our multi-mode coupler model, they've been enhanced to simulate more advanced coupling configurations, allowing the user to specify a launch system in terms of either optical elements or by a black box imaging system. And we also have a new test bench for measuring chromatic dispersion and dispersion slope in a multi-mode fiber. So I went through that very quickly. I could not cover all of the new updates. So for a more detailed explanation, please go visit our website. You can see the web address here. And if you'd like to chat or set up a live demo, make an evaluation, please feel free to reach out, contact me. My email's here. And with that, I'd like to thank you for your attention.
Chris.Maloney at VPIphotonics.com, and he's a really, really good guy to have a chat with. I know because I spend a lot of time in the virtual exhibitions, the real-time exhibitions. Remember Photonics West? Thank you very much for being with us today. It is very clear to me that all the designers of optoelectronic devices should be talking to you. But what is the particular companies that you have in mind that you think this is in general interest for them?
Yeah, so there's a few different companies. So those who are making photonic components that are utilizing the PIC foundries. We have interfaces. And we support the PDKs for various indium phosphide, silicon nitride foundries. So if you're trying to take your photonic integrated circuit idea and have it fabricated, please feel free to reach out to us, and we can help. We can help you get in the door there.
We have done quite a lot of meetings on data center interconnects, and the idea now of having a full network based on PAM4 is really in everybody's interest. It is everybody's looking at the VCSELs for multi-mode and the silicon photonics for single mode. You have a tool in which people can actually explore these two solutions and then have a real answer to this question, correct?
Exactly, and that's actually one of the main benefits of doing this in the software is, especially right now when many people can't get into the labs, you can explore those different ideas through software, and it's much cheaper, it's much faster. You don't actually have to have the components on hand. and you can explore those ideas.
I've been a user of VPI software, so I actually have to tell you, it's very easy to use software, very, very easy to use software. The idea of having everything building block based and being able to double click and add the parameters is a paradigm shift already for many years in this industry. So congratulations, Chris, from VPI on this. I'm gonna go to QuiX, back to Jelmer. And the reason for that is there is a question in YouTube for you, which is very, very interesting. From TU Eindhoven, they are asking, how many qubits can it scale up until the loss of the waveguides are becoming an issue?
Okay, so we expect that we can certainly get to above 50 optical modes before we run into loss issues.
You are doing this fabrication on silicon nitride platform
Yes.
with very, very low losses.
Yes, that's absolutely. So I didn't actually discuss in the talk how we make the processor, but indeed the use of the silicon nitride platform, because of the low loss and high component density, is absolutely vital for this application. It
is really a paradigm shift what you are setting up, Jelmer. Anybody that helps QuiX is also helping the quantum community and helping a little bit of EPIC. So please all help Jelmer developing this, because it's really, I mean, we are leading right now the quantum processing with photonic integrated circuits, thanks to QuiX and thanks to the cooperation they have with Lionics and with Fix. Thank you very much. We continue with the program. And now I go to one of my favorite companies in the world. I go to Munich and I go to TOPTICA, because as a laser fan, you need to love TOPTICA. TOPTICA got last year the Prism Award at Photonics West, and now they are going with a CW optical parametric oscillator fully hands-free. They call it the TOPO. I really want to know more about this, and there is no better person to tell us about this than Adam Heiniger, product manager for the DLC TOPO. Thank you very much for being with us today, and tell us about this hands-free optical parametric oscillator. The floor and the attention of everyone goes to Munich, goes to Bavaria, goes to TOPTICA. The floor is yours.
Thank you, Jose, for the introduction. I am Adam, the product manager of TOPTICA's TOPO. At TOPTICA, we make CW tunable diode laser systems, and we make ultra-fast femtosecond lasers based on fiber oscillators. And we like to call ourselves the all wavelengths company because we can make these systems to target almost any wavelength that our customers might need us to provide. And this system in particular we made because there's a gap in high power, widely tunable CW lasers between about 2 to 4 microns. Below this wavelength range, we have TOPTICA's suite of tunable diode laser systems, but they can cover about 200 nanometers up to 2 or 2.5 microns. Above this range, quantum cascade lasers are available, but within this range, there really is nothing that can provide direct emission from some gain medium. This is an important wavelength range for scientific applications like molecular spectroscopy, integrated photonic devices for trace gas detection, and even some quantum technology platforms are starting to look at molecules to provide quantum sensors or computers or these kinds of things. Also commercial applications like optical component characterization, thin film characterization, this kind of thing in the infrared. But like I said, there's no source of direct emission, so TOPTICA turns to nonlinear optical tools to provide this wavelength range. So in optical parametric generation, we can rely on high power lasers that are available in the near infrared and use them to pump this optical parametric process, where one pump photon gets converted in a nonlinear crystal into 2 lower energy photons, where the sum of their energy adds up to the energy of the pump photon. And so that's what you see here. In this process, the lower energy photon is called the idler, and the higher energy photon is called the signal. But unfortunately, this process is somewhat inefficient. We can improve the efficiency by using these high power pumps that I mentioned, but we can also put this nonlinear crystal inside of an optical cavity that is resonant for the signal photon, or it could be either one of the output photons. But we choose the signal photon. And when this process happens, that signal photon stays trapped in the cavity and again cycles through that crystal. And then instead of a spontaneous process, we have a stimulated process, essentially difference frequency generation between that signal and the pump. And in this way, we can get high power and in better than 50% conversion efficiency from the pump into the signal and the idler outputs. This product is called the TOPO. It looks like this. It's pumped at 1 micron with an ytterbium fiber laser, and it provides tunable output, the signal covering 1.45 to 2 microns, and the idler 2.2 to 4 microns. In the idler tuning range, where most of, which essentially is what's filling this 2 to 4 micron gap, we can provide continuous coverage. We can tune mode hop free over up to more than 300 gigahertz. The line width of the system is less than 2 megahertz, and we can provide watt level powers in these wavelength ranges. The main application is typically molecular spectroscopy for systems like this, and we've shown that the system can be used to do molecular spectroscopy over the entire range of the idler, really in one automated sweep. All of the tuning actuators for this system are hands-free. They're all computer controlled, and we provide software that can use a wavelength meter as a reference so that you can essentially dial in the wavelength that you want in this range, or you can program in the scan that you want. The idler will tune. It may have a mode hop at some point, but the wavelength meter can detect this mode hop. It can go through a lookup table to find where it left off before the mode hop, and then continue again, so that you can just set the system to scan over the range of interest. You can walk away, and when you come back, your experiment is done. And that is basically it. The system at a glance, again, here in my contact information.
Adam.Heiniger at TOPTICA-USA.com. But TOPTICA is a very European company in the center of Bavaria. Thank you very much, Adam, for being with us today. And thank you for this fantastic development. I really, really love the way that you keep pushing the technology to satisfy the different needs. And today you came with a product which is a mid-infrared scanning solution for checking the different compounds that could absorb light in the mid-infrared technologies. You talk a little bit about the application being detection of molecular. Are we talking about gas sensing? Are we talking about solid sensing, pharmaceutical? Which are the companies that you think have to pay special attention to this wavelength band?
Yeah, in particular, this type of high-resolution spectroscopy is beneficial for gas sensing. It can, of course, be used for solids and liquids as well, but there typically the features are broader, and so maybe you don't need something this high resolution, although certainly the system is good for those applications as well. But it really shines in gas sensing applications where features are really narrow.
Mid-infrared is getting a lot of attention right now in all the industries. Actually, I can tell you already, Adam, that next year we're going to make a huge push for mid-infrared photonics in Europe. When it comes to the optics and the fibers, not everything is available there. Not everything is there. Is there lacks, holes in the supply chain on the fiber or on the optics for this wavelength range?
Yeah, so we have to work and develop some of our vendors to provide some of the coatings that we need in this type of thing. And certainly where we are limited, we do see some limitations in available fibers to fiber couple the output of the system, for example.
Fantastic. I am always very interested in companies working together. One thing that I'm always very curious from TOPTICA is the different activities that you have from LiDAR all the way to today you presented gas sensing, the quantum technologies. For me, lasers are nothing with the right beam shaping. So I'm going to see there is some potential cooperation with one of my friends. I'm going to go to France. I'm going to go to QuiX because I have with us Tiffany from QuiX. Is there any room for cooperation? What does QuiX do? How do you do beam shaping?
Yes, for sure. Can you hear me? Yeah.
Loud and clear.
Right. Yes, for sure. There could be cooperation between our two companies. We do beam shaping, in fact, by working on the mode of the light by changing the shape of the light. And we can work on several wavelengths with continuous laser, with ultrafast laser. And basically, we can do any shape the customer would like to do, depending on the application for surface texturing, or it can be also for laser welding. And we also have application in microscopy. So it's really a link between the laser manufacturer and the final end customer user needs, so we can make the perfect shape for his application. So I would be very happy to maybe get more in touch with you, Adam, so that we could see if we could make synergy between our two companies and see how our two products can work together.
Indeed, I think there's always room for cooperation here, Adam. And I wanted to introduce you to another member of EPIC today. It's their first day as a member. Welcome, Joanna from Mintres. Joanna, you are bringing ceramics to the photonics industry. Could you tell us in a few words what you could do for laser companies like TOPTICA that we have in the room, or Opton Laser we also have in the room, Laurent?
Thank you so much, Joseph, for introducing. Yes, indeed, we work a lot with the laser suppliers. So usual laser for us means overheating, high temperature, and that's what Mintra's usual brings. So we targeting those overheating areas, especially in photonics. You know very well that high power consumption needs efficient cooling, and we work not on the packaging, we're working exactly at the source of the heat. So usually we provide ceramic or diamond spreading, efficiently distributing the heat and allowing to work even with the higher power lasers than what you can access right now. So normally we provide custom-made solution because every design is so different that you really have to also provide efficient heat spreader for that.
Thank you very much. And for Adam, we all got the message. You have a fantastic optical parametric oscillator, can enable the wavelength around 3 micrometers for spectroscopy and other applications, and fully suitable to any real-time processing. So we are looking for customers on this. The challenge on the table, you have application for this, contact Adam or contact me and I make the introductions. I love doing that. And Adam, stay tuned because you're gonna love the next presentation. We continue in Germany, but now we go to my favorite city because it's full of photonics companies. We go to Aachen and we meet a good friend of mine. We meet Tobias Müller, CTO of Aixemtec, who's going to tell us why photonic manufacturing can be digital, a company that is setting up the stone of active alignment for manufacturing of optoelectronic devices, equipment for manufacturing of optoelectronic devices. Is going to tell us that it's all software driven. Let us hear that from Tobias Müller. Tobias, thank you very much for being with us, and thank you for telling us how Aixemtec is making a difference in assembly of optoelectronic devices. The floor is yours.
Thank you very much, Jose, for that kind introduction and also for having me here. Let me see. I need to share the right screen, screen 2. Can you see my presentation now?
Yes, crystal
excellent. Yeah, so thanks a lot, and it's nice to see you all online. Today I want to tell you how we indeed make a difference through our software when it comes to packaging, assembly, and testing of optical or electro-optic systems. So I want to introduce to you, I can only scratch the surface, I got only a few minutes here, but I want to show you our open machine software ecosystem. First, few words to our company. Who are we? We are making precision assembly and testing machines and services. Our technological excellence goes back to the machine you see here on the left-hand side. It is a very flexible precision assembly platform which we utilize for multiple applications, as you'll see in the next slide. We consider our mission to enhance and accelerate our customers' R&D and production. So we want to really help them to make the step into the market and use our flexibility and also our development speed to make their new products put them into reality. Therefore, we use the hardware, of course, but more importantly, I think even is the intelligent software framework, which is below what you see. And this makes it possible for us to give open access to our customers for their own enhancements, as you'll see in the next slides. And by the way, we also offer machines and services, so we can make the technology accessible for our customers without purchasing the equipment, but make use of our assembly and packaging services, or those of our partners. Well, this slide I will actually more or less skip. The message is we are pretty diversified in terms of markets. We're only 4 years old, doubled in size, in turnover, and in floor space every year. Now we are 26 people in the meantime. So I like to start my actual topic of today. The software, and I like to cite my valued colleague Matthias Höschemer from CSEM. He uses this image to outline that what you see in terms of modularity is only the tip of the iceberg. What really makes a machine usable, flexible, and reconfigurable is what is beneath, and that's what people usually do not see. And so the state of the art is kind of, you code on the machine in a defined language with, well, at least limited extendability. I mean, there's been happening a lot in the last years, but the usability is still a little bit, let's say, can be improved, at least to our understanding. And so we have kind of a way of thinking that a machine should more integrate into the code of a developer if he's in developer mode. Of course, for production, that's a different story. But that's why we fully model our machine in an R&D development framework and make accessible every single function of this machine in a very comprehensive way. It allows to add open source libraries and use any sensor, and ultimately makes our customers very fast and very innovative. And I'd like to draw an analogy towards smartphone industry. So, you know, what really made the change? It is, if you look at the Google and Android framework, what customers needed to have is operators need easy to use software, and that's the usability that's important. Engineers need to have a platform which is easy to develop, and developers need to make it easy to implement. And this is what we try to integrate into that machine platform. So now I want to address these specific 3 dimensions. So firstly, the operator. So what's in the focus for an operator? It's the stability, the ease of use. So how do we manage this? We make it as easy as possible for him. So he just enters the product, which process needs to be used, which machine modules to use, puts in the job data, how he's feeding parts into the machine. And yeah, we have a customer voice here stating, thankfully to Mr. Forrer, that we create very user-friendly machines. So, but this is, I think, pretty much state of the art. Now, looking to the developer, this is getting more interesting. Again, stability, ease of use, and control is in their focus. So they need open access frameworks, open hardware interfaces, open software libraries for artificial intelligence, deep learning, standardized software tools, and yet that needs to work. And I can't give you a demo right now here. You're free to request one, but I'm telling 5 lines of code is enough for active alignment. And this is justified or tested. We got this testimonial from QN from Trumpf spin-off. Our open access development gives them the control they need for developing new products. And lastly, and I think most interestingly, I want to show you the mixed reality. So the coding, the scripting opportunity for engineers. And this is kind of, you can imagine it like a launcher on an Android smartphone. So we can make customized HMIs. And here's one that Fraunhofer IPT made for themselves. And what is it actually doing? We can do drag and drop process development here on our tool. So we just put in motion. This is move tool to a specific pose. So now we edit pose 1 and 2. And here, this is make a measurement. And so we capture an image here. And then just by configuring these process building blocks, we just check, okay, which camera is chosen. It's the top side camera. And then we identify or put in the positions where we want to go, save it. And then on the next step, you see we can execute this movement or this little subroutine process right away. So it's just a process which we just programmed before, play it, and you see here the virtual machine is now moving. So first thing is to do an inspection. And here you will see a simulated image. So this is a hole. So we just add to random position. We don't really know exactly where it is. Inspect this hole and then insert a dispenser needle into this specific hole. It's just a cheap demo process, but just to give you an idea, in 1 minute or even less, you can make such a drag and drop coded process. And this is now available. Made by our friends from IPT, and this is how they use our machines to make these processes, and we can now make it available for everyone, basically. So, and if you still need help, if it's not comprehensive enough, we can support with augmented reality. So you see here, this is an X-ray view into one of our machine modules, helping for maintenance, but also frequently used to help people do their process development. What's next? Get in touch and request an in-depth live demo. So as I mentioned, this is just scratching the surface here. But we'll be more than happy to give you a more detailed presentation of how the details work and how we can make a difference for you. And I
Tobias,
hope I didn't take too much time.
You were great, and you had the QR code there. I encourage people to scan it at info@aixemtec.com. Contact Tobias and request a demo because it's really out of this world. I'm very, very amazed, Tobias, with what you are achieving.
Thank you.
But today, from the very beginning, from the first time I met you, you always told me about one word: reconfigurability. You wanted your machine to be reconfigurable, and you took that to the extreme today, making modules and making people access those modules and being able to, from one process to another, being able to modify the machine. Photonic integrated circuits is aiming to many different markets, and the companies who are manufacturing PICs, they need to be able to adapt to different products. What kind of companies you think they are should be mostly interested about this fast reconfigurable machine?
To my understanding, it's most interesting for process development R&D departments and for institutes who need to have tons of different applications on maybe a similar equipment. And this is how we also used it at Fraunhofer time. So we started automating all kinds of different processes. So that's for the R&D mode. For the production mode, I think there's different foci points. So it's more on real-time process control. It needs to be, very reliable, very easy. So I think for the R&D, it's more to the engineering and developing companies, and for the production, the shop floors, we also we're addressing them too, of course.
We shared a lot today. We learned a lot from each other. It was really fantastic. In only 1 hour, we can cover so many different technologies, so many different applications. I'm really amazed with what QuiX is doing. Did you see already quantum computing on a photonic integrated circuit that was out of this world? I really want everybody to keep knowing what the photonics can do for each other. We need to keep enabling these contacts. If you want to get in touch with any of the participants today, send me an email, jose.pozo@epic-azo.com, and I will make the introduction. Please make sure that you find room for cooperation, because this is what the 651 members want to do with EPIC. On behalf of a super hot team of experts in the medical, in the integrated photonics, in the laser, in the quantum, an innovation manager, marketing experts, and of course, Carlos Lee behind all this adventure, I would like to encourage all of you to wear a mask, to wash your hands, to stay healthy.